Okay, I'm going to continue with 4.2b notes, and to finish example 1, we're trying to use 4 rectangles to now estimate the lower sum for the area bounded in the region. So the last video we finished finding the area of the circumscribed rectangle. So we found an upper sum, we found an over approximation of the actual area of the curve. So now we want to draw rectangles so that we have inscribed rectangles and an underestimation. Okay. So we want to draw rectangles in a way so that the corner that connects to the graph will cause the rest of the rectangle to fall beneath the curve. Okay, so in this case, the graph is increasing, and now it's going to be the upper left endpoint of each rectangle that will cause the gaps to show up beneath the curve. And we purposely want the gaps to show up beneath the curve because we're looking for an underestimation. We're trying to find the lower sum. So the width is still going to remain as 1/2. But for the first rectangle, you see that the first rectangle is going to be the left endpoint that connects to the curve. So we want to choose the corner that is connected to the curve, because that point is going to be what is going to give us the height of each rectangle. So for the first rectangle, it's going to be f of 0. So if I plug 0 into the function, f of 0 will give me that point, and that point represents the height of my first rectangle. So that's f of 0. For the second rectangle, my height is at f of 1/2, or f of 0.5. For my third rectangle, my height is at f of 1, which is that point right there. And for my fourth rectangle, I want my height to be at f of 3/2, or f of 1.5, which will give me this point, and will determine the height of my fourth rectangle, and we want portions of the rectangle to be below the curve, and that's the case. Okay, so f of 0, f of 0.5, f of 1, f of 1.5. We found these values well, actually we didn't find f of 0. F of 0, plug 0 in for x, we get 0 squared plus 1, which is 1. But we found f of 0.5, f of 1, and f of 1.5 from the previous upper sum. So we can simply multiply and combine those sums together. So width times height, width times height, width times height, width times height. We add all the areas of the 4 rectangles together, and we get a lower sum, 3.75. And it makes sense that your lower sum is going to be smaller value than your upper sum. Right? Your overestimation should be a larger value compared to your lower sum. Now, a good approximation for our actual area, given our restriction of 4 rectangles, is simply finding the average between the upper and lower sum. Right? If we know that this is a overestimation, this is an underestimation, then to find a better approximation is we find the average of these two values. Now, it doesn't mean that this will give us the exact area. Okay, notice that this is simply going to give us a better approximation. Okay, next topic is midpoint rule. So similar to the upper and lower sum of drawing rectangles, but now we're going to use the midpoint of each rectangle's x value to calculate the rectangle's height. Okay. So example 2, estimate the area under the curve 8 over x squared plus 1 from 2 to 6. Use midpoint rule with 4 subintervals. So we want 4 rectangles. Width, again, is b minus a over n. My a and b value is 2 and 6, so 6 minus 2 over 4. 4 is the number of rectangles we want. So we get 4 over 4, so the width of each rectangle is going to be 1. Okay, so here's our curve. Y is equal to 8 over x squared plus 1. We have a graph that is decreasing. We want to find the area, estimate the area of between the curve and the x-axis, and between the x values of 2 and 6. So starting at 2, we can increment by our width and go until we get to our endpoint. So from 2, we add 1, we get 3. We add 1, we get 4, 5, and then 6. Okay. Now the way that we draw the height of each rectangle is going to be a little different. we want to identify the midpoint x value of each rectangle, and once we find that x value, we're going to take that x value and we're going to extend it until we hit the curve. Okay, until it extends and attaches itself to the curve, because we want the midpoint x value to determine the height of each rectangle. Okay, so so in this case, for my first rectangle, my x value, my midpoint will be 2.5. So we want to use 2.5 to find the height for my first rectangle. Okay, so this is what we call a midpoint or middle rectangles. So here, this is 3.5 extended to the curve. This here is 4.5 extended to the curve, and then 5.5 extended to the curve. Okay, so the midpoint sum, okay, the width is going to be 1 for my first rectangle, but my height is going to be f of 2.5, right? And we'll figure out f of 2.5 a little bit later. For the area of my second rectangle is width times height. Third rectangle, width times height, and finally width times height, 1 times f of 5.5. Okay. So if I want to find the height of each rectangle, I'm going to plug the midpoint x value into each of into the function. So 2.5, plug it in for x. Okay, 8 over 2.5 squared plus 1. We can use our calculators to find these values. Plug 3.5 in for x, 4.5 in for x, 5.5 in for x. And we're going to get these values, which represents the height of each middle rectangle. Okay, so then we simply add the areas together. Okay, all these heights are multiplied by 1, so they're not going to change. So we add the areas together, and we're going to get 2.34. Okay, so the question is, why would midpoint sum be a better approximation of area than the upper and lower sum? Okay, upper and lower sum will give us an over approximation, under approximation. Midpoint sum may give us an under or an over approximation, but it will give us a better approximation than the upper and lower, because we have portions of the graph that lie above and below the graph. So this kind of evens things out a little bit and gives us a better approximation. However, one thing to note is that your midpoint sum is not the average between your upper and lower sums. Okay, so what we just found from the previous page here, when I talked about a good approximation is to find the average between those two. This average is not going to be the same as using the midpoint rule. Okay, so just make sure you're aware of that.